A Constantan wire A SWG 28 and B SWG 32, each of length 1.0 meter, are connected separately to a circuit. A current of 0.15 ampere flows through each wire and produces potential difference of 0.20 volts across wire A and 0.40 volts across wire B. The diameter of wire A and wire B are 0.32 millimeter and 0.22 millimeter respectively. Calculate the resistivity of each wire. Okay, now how do we calculate this? You notice that the same current, the two wires, the two Constantan wires of different model, we have SWG 32, SWG 28. Two of them are Constantan wire but of different diameter. So in that case, we are going to use Ohm's law to find the resistance of the wire. From Ohm's law, we say V is resistance of this wire is VA over current. The same current flows in two of them. So we have VA, voltage across wire A. The voltage across wire A is 0.2, that's 0.2 over current is 0.15, that gives me this. So the area, area of wire, this wire here, the area of this wire is given as pi d square over 4. I put A here because it's wire A. So I have, if it is wire B, I'll put B here for this one. So I'm dealing with wire A. That's why I put A here. So we have pi d square over 4 is the area of this wire, which is pi is 3.142. D, the diameter of wire A and wire B. This is diameter of wire A. This is the diameter of wire B. So which is 0.32. Convert this millimeter to meter, you multiply by 10 raised to the power of -3. So that gives me, all divided by 4, you square it because here has a square. So that gives me this result. So with this, I have this result here. This multiplied by this one, divided by this, will give me this result. So the resistivity, this is a symbol for resistivity, that is rho. I use this rho to denote resistivity. That is resistivity for this wire A. Resistivity of wire A is given as resistance of wire A multiplied by area of wire A over length of wire A. So this length, both wire A and wire B have the same length. So that is 1 meter. So resistance of wire A is this one here, which is this. Area of wire A is this one here, which is this. The length of wire A is 1. So this multiplied by this is going to give me this. So this is the resistivity of wire A. You can also find the resistivity of wire B using the same model. So what I'm going to do now in this case is, this place is going to be RB, that is the resistance of wire B, potential difference of wire B, which is given as 0.4. Current is the same, so you find the resistance. The area of wire B, you replace this A by B, pi d square, this will be B, that is 0.02 over 4. You do that. Resistivity of wire B will give you resistance of wire B. You place B here. If you are dealing with wire B, that is this wire here. The area of wire B, length of B is the same length. So you solve it and drop your answer in the comment section. Thank you.